Well, hello everybody. Welcome to week two. And so in this lecture, we're going to talk a little bit about some of the things that I want to highlight from chapter two, which is really focused on how do we actually describe the distribution. So we talked about some of those aspects about a distribution last week from chapter one. Now, how do we begin to describe that distribution using pictures? One of the things that I think is always important to remember anytime you're doing any kind of data analysis is the importance of pictures. You should always attempt to draw the picture first. Because, as the saying goes, picture's worth 1,000 words. And that's definitely true when it comes to the principles of data analysis. So, for example, we talked about numerical distributions and categorical distributions last week. We talked about how important it was for you to be able to distinguish between those. And this week, you're actually going to see why. But up under numerical distributions, right, we're typically interested in the shape, right? So that's one of those aspects of a distribution that we talked about. We're interested in the center, and we're interested in the spread, right? So all three aspects are important things to look at with respect to numerical distribution. In terms of categorical distributions, it's a little bit different. Generally, we're interested in something called the mode, which is kind of like a substitute for the center, right? So the mode would be the most frequent category that appears in our distribution. We're also interested in variability or diversity, which is sort of akin to the idea of spread, right? So how many different categorical I should say this way, how many different categories do we have? So depending upon whether or not we're interested in a numerical distribution or categorical distribution, right, the ways in which we would attempt to describe those distributions would be different. So when we talked about the shape, center, and spread last week, we're really primarily talking about numerical distributions, right? But now we see how we can look at these things. So once again, if we think about the three aspects of a distribution, the idea of shape, we're once again talking about symmetry and how many bumps or modes there is, the distinguishing features. We talk about the center. We're talking about what the typical value is. And once again, we're talking about spread, right? We're really interested in all the data all close together. So I wanted to come back to this because once again, it doesn't really matter if we're talking about numerical or categorical. We're really always sort of interested in describing these things. And so this week, right, you're going to focus on how to describe these things using graphs. But next week, actually, we're going to finally move and start talking about how we can actually use statistics, usually called descriptive statistics, to describe these things. Okay? So, you remember last week we talked about normal distribution and how it has the following properties. Some of this is just kind of review. That is that it's symmetric, it's unimodal, it's mound or bell-shaped. Okay. So one of the things you're introduced to in chapter two is the idea of what happens when the distribution is not normal, right? And so there can be something called skewness that's introduced into your distribution. So for example, a distribution is skewed right if most of the data values are small and there is a tail of larger values to the right. So it looks kind of like this, right? This is a right skewed, sometimes called a positive skew, in the sense that most of our values are small. By that I mean, you notice our highest frequency is between the 0 to 50 category. Definitely most of the numbers are between 0 and 100, with there being almost none that are above 200. Okay, so this has a tail, if you will. So out there where you see the 250, that'd be the tail. So this is a skewed distribution. You can also have a left skewed distribution, right? And it's kind of the reverse of the right skewed. So this time, the majority of our numbers are large, with there actually being a tail of smaller values to the left, okay? So either one of these distributions are skewed. And this will be something be important because a lot of the statistics that you're going to learn really depend upon having a normal distribution. If your distribution is like either of these two, then there'll have to be some adjustments, right? And we'll talk about that next week when we start actually learning statistical tools for describing distributions. So the question is, well, what's happening here, right? Why are these distributions being skewed? So you're also introduced to the concept of something called an outlier, right? And an outlier is a data value that's either much smaller or much larger than the rest of the data. And so if you think about those distributions that we just looked at, right, those extreme values, if we can go back here, right, so in the top photo, right, the numbers that would be above 200 would clearly be outliers, right? These numbers are kind of unique and they're really out there. Same thing on the bottom, numbers that are between 0 and 20 would be outliers. And they're the things that kind of pull the distribution outward. And so some reasons for outliers, well, there could be an error in data collection, right? Sometimes, I've had problems where we tried to enter data and somebody accidentally enters another 0, right? So we've got a janitor making $100,000 a year who's really only making $10,000, right? Part-time. But it's listed as 100,000 because somebody put an extra 0. So that's clearly an outlier. It creates extreme effect. And then sometimes it's possible that, there's really no error, right? It could be that, a person's number really is their number. It's just so different from the rest of the people, right? So owners of companies and CEOs of companies, it's no mystery, tend to basically earn salaries that are far in excess of, say, the typical or low-wage worker in their organizations, okay? So what are some graphs that you're going to learn that would help you to identify, right? Whether or not your data is normally distributed or if there's a skew, and potentially are there some outliers? Well, there's basically 4 graphs that you're being introduced to in this. Well, there are more in this chapter, but there are 4 that I want you to focus on. And so the first is something called a histogram. And you would use a histogram when you are attempting to display numerical data. So remember those 3 things that you can get with numerical data. Okay? So in a histogram, different bin widths, right? And those are basically the little where you see the numbers at the bottom, 0 to 5, 5 to 10, 10 to 15. Right? So obviously the bin width here would be 5. Okay? And one of the things that's important about histograms is that depending upon what your bin width is, right, that can actually end up making your data look quite a bit different. Okay. Smaller widths show more detail. However, too small a width shows too much detail and will not clearly display the main features. And that's kind of what you're seeing between the 2 examples. Both of them are attempts to display tip amounts. Another plot or another graph that you can use for numerical data is something called a stem and leaf plot. And believe it or not, it's giving you the same information that you're getting with a histogram, except this is kind of like a histogram turned on its side. And you're actually given more information because these sort of reflect the actual values that are in your distribution. So the leafy part, so if you look at this picture, for example, it kind of looks like a leaf, right? So the leaf is the last digit, okay, in that number, okay? The stem contains all the digits before the last digit, okay? And so once again, we're getting actually richer data here because it's showing each of the individual data values, okay? It's sort of the same as a histogram, but the bin width is in a power of 10. So for example, the way we would read these is that we have basically 2 numbers that are in the teens. So if we go up to that top, we see the 1 there. 1-4 means that there's 14. 1-7 means that there's 17. Okay, then we go up a power of 10 to the 20s, right? So we have a 22. Notice we have 2 25s. Okay, and then we have a 28, right? So that's how you would sort of read that. Okay, and so they're same as a histogram, but in this case, a bin of 1. Okay. Um, Look at that other one. 5 zeros show that there were 5 classes with 40 students, right? So notice the 5 zeros after the 4, right? That means there were 5 40s, right? So hopefully you kind of got the hang of how you might sort of interpret these. So once again, both the histogram and the stem and leaf plots are graphs that you would use solely for numerical data, okay? But what if we have categorical data? Well, we really shouldn't be using the histogram and the stem and leaf plot, even though oftentimes people do. Instead, there are actually 2 types of charts that we ought to be using when we're dealing with categorical data. There's something called a bar chart. It looks like a histogram, but it's different. Okay, and then there is a pie chart, which definitely looks different from a histogram. So let's look at a bar chart for Army ranks, right? So once again, remember categorical data is to display categories. So this would be a way we might display the frequency of, say, corporals, majors, privates, and sergeants within, say, a company or a battalion right, in the Army. Okay. Notice the difference between a bar chart and a histogram. Notice these bars are not touching. Right, and that's because this is categorical data. In a histogram, the data is numerical, so it would be continuous in the way that it's spread out, but not the case for a bar chart. Okay. A pie chart looks like this, right? So it's the same data, but displayed in different places, right? Many people tend to prefer pie charts, and you can see why. They're colorful, and you kind of get a lot of information just by looking at them. Okay. So in terms of the charts that I want you to kind of hone into, once again, there are 2 for numerical. There's the histogram and the stem and leaf plot. And then there are 2 for categorical data, bar chart and pie chart. What you'll have to do is to do your darndest to remember not to mix these things up, right? And that is, don't do pie charts for numerical data. Don't do stem and leaf plots for categorical data. Okay, so here is where we end our lecture today. Once again, hopefully through reading the chapter, taking a look at this. Don't forget to look at the my StatCrunch video on how to calculate these things using StatCrunch. Hopefully you'll get a feel for just the ways in which they're used to display different data. Of course, remember, you can always contact me. Okay, take care. Have a great week.